I'm really, really excited to be here today because I'm about to show you some stuff that's just ready to come out of the lab, literally, and I'm really glad that you guys are going to be amongst the first to be able to see it in person because I really, really think this is going to really change the way we interact with machines from this point on. Now, this is a rear projected drafting table. It's about 36 inches wide, and it's equipped with a multi-touch sensor. Now, normal touch sensors that you see, like on your kiosk or interactive whiteboards, can only register kind of one point of contact at a time. This thing allows you to have multiple points at the same time. I can use both my hands. I can use coordinating options. I can just go right up and use all 10 fingers if I wanted to. Go like that. Now, multi-touch sensing isn't completely new. I mean, people like Bill Buxton have been playing around with it in the 80s. However, the approach I developed here is actually high resolution, low cost, and probably most importantly, very scalable. So the technology, isn't the most exciting thing here right now, other than probably its newfound accessibility. What's really interesting here is kind of what you can do with it, and the kind of interfaces you can build on top of it. So let's see. So, for instance, we have a lava lamp application here. Now you can see, I can use both of my hands to kind of squeeze together and put blobs together. I can inject heat into the system here, or I can pull it apart with two of my fingers. It's completely intuitive. There's no instruction manual. The interface just kind of disappears. This started out as kind of a screensaver app that one of the PhD students in our lab, Ilya Rosenberg, made. But I think its true identity comes out here. Now, what's great about a multi-touch sensor is that, I could be doing this with as many fingers here. But of course, multi-touch also inherently means multi-user. So Chris could be out here and interacting with another part of lava while I kind of play around with it here. You can imagine a new kind of sculpting tool where I'm kind of warming something up, kind of making it malleable, and then kind of letting it cool down and solidifying in a certain state. Google should have something like this in their lobby. I'll show you something a little more of a concrete example here as this thing loads. Now, this is a photographer's lightbox application. Again, I can use both of my hands to kind of interact and move photos around. But what's even cooler is that if I have two fingers, I can actually grab a photo and then stretch it out like that really easily. I can pan, zoom, and rotate it effortlessly. I can do that grossly with both of my hands, or if I can do it just with two fingers on each of my hands together. If I grab the canvas, I can kind of do the same thing. Stretch it out. I can do it simultaneously where I'm holding this down and gripping on another one, stretching this out like this. Again, the interface just disappears here. There's no manual. This is exactly what you kind of expect, especially if you haven't interacted with a computer before. Now, when you have initiatives like the $100 laptop, I kind of cringe at the idea that we're going to introduce a whole new generation of people to computing with kind of this standard mouse and Windows pointer interface. This is something that I think is really the way we should be interacting with machines from this point on. That's great. Now, of course, I can bring up a keyboard. And I can bring that around, put that there. Now, obviously, this is kind of a scanning keyboard, but of course, I can rescale it to make it work well for my hands. And that's really important because there's no reason in this day and age that we should be conforming to a physical device. I mean, that leads to bad things like RSI. I mean, we have so much technology nowadays that these interfaces should start conforming to us. I mean, there's so little applied now to actually improving the way we interact with interface from this point on. This keyboard is probably actually really the wrong direction to go. You can imagine in the future, as we develop this kind of technology, a keyboard that kind of automatically drifts as your hand kind of moves away and kind of really intelligently anticipates which key you're trying to stroke with your hands. So, again, isn't this great?
Where's your lab?
I'm a research scientist at NYU in New York. Here's an example, another kind of app. I can kind of make these little fuzz dolls. It'll kind of remember the stroke that I'm making. Of course, I can do it with all my hands. It's pressure sensitive, you can notice. But what's neat about that is, again, I showed you that two-finger gesture allows you to zoom in really quickly. Because you don't have to switch to a hand tool or the magnifying glass tool, you can just kind of continuously make things in real multiple scales all at the same time. I can create big things out here, but I can go back and really quickly go back to where I started and make even smaller things here. Now, this is going to be really important as we start getting to things like data visualization. For instance, I think we all really enjoyed Hans Rosling's talk, and he really emphasized the fact that I've been thinking about for a long time too. We have all this great data, but for some reason it's just sitting there. We're not really accessing it. And one of the reasons why I think it is is because of things like graphics. It will be helped by things like graphics and visualization and influence tools, but I also think a big part of it is going to be starting to be able to have better interfaces to be able to drill down into this kind of data while still thinking about the big picture here. Let me show you another app here. This is something called Whirlwind. It's done by NASA. Now, it's we've all seen Google Earth. This is kind of an open source version of that. There are plugins to be able to load in different data sets that NASA's collected over the years. But as you can see, I can use the same two-finger gestures to kind of go down and go in really seamlessly. There's no interface again. It really allows anybody to kind of go in and just does what you kind of expect, you know. Again, there's just no interface here. The interface just kind of disappears. I can switch to different data views. That's what's neat about this app here. There you go. NASA's really cool. They have these hyperspectral images that are kind of false colored, so it's really good for determining vegetative views. Let's go back to this. Whoops. Now, the great thing about mapping applications, it's not really kind of 2D, it's kind of 3D. So again, with a multi-point interface, you can kind of do a gesture like this. So you can kind of be able to tilt around like that, you know. It's not just simply relegated to the kind of 2D panning in motion. Now, this gesture that we developed, again, it's just kind of putting two fingers down, it's kind of defining an axis of tilt, and I kind of tilt up and down that way. That's just something we just came up with on the spot. You know, it's probably not the right thing to do, but there's such interesting things you can do with this kind of interface. And it's just so much fun playing around with it, too. And OK, so the last thing I want to show you is, you know, I'm sure we can all think of a lot of entertainment apps that you can kind of do with this thing. I'm a little more interested in the kind of creative applications we can do with this. Now, here's a simple application here. I can kind of draw out a curve. And when I close it, it becomes a character. But the neat thing about this is I can add control points. And then what I can do is kind of manipulate them with both of my fingers at the same time. And you notice what it does. It's kind of a puppeteering thing where I can use as many fingers as I have to kind of draw and make. Now, there's a lot of actual math going on under here for this kind of to control this mesh and do the right thing. I mean, this is this technique of being able to manipulate a mesh here with multiple control points is actually something that's state of the art. It was just released at SIGGRAPH last year. But it's a great example of the kind of research I really love. Kind of all this compute power to apply to make things kind of do the right things, the intuitive things, do kind of exactly what you expect. So multi-touch kind of interaction research is a very active field right now in HCI. I'm not the only one doing it. There are a lot of other people getting into it. This kind of technology is going to let even more people get into it. And I'm really looking forward to interacting with all you guys over the next few days and seeing how it can apply to your respective fields. Thank you.